Okay, some more problems from section 4.7, and this is 47, and the directions on these. Use a sketch to find the exact value of each expression. So it's something we can get into a little bit better, drawing these sketches. So this was what we're looking for is the cosine of the angle whose sine, remember this is the angle whose sine is 4 over 5. So I'll just draw a sketch, and remember the values of these sines are going to be in the the inverse sine will be in the first and the fourth quadrant. Since it's positive in the first quadrant, so my angle will be in the first quadrant. All right, so I know that much. So let me draw just a quick sketch here. And I'll draw just a triangle in that first quadrant. Hope you guys can all see that. And this is my angle theta, so that's what I'm looking for. Okay? Now the sine of theta is going to be, this is a right angle, of course. And the sine of theta, remember from SOHCAHTOA, the sine of theta is the opposite over the hypotenuse. See, this is going to be the opposite over the hypotenuse. That's the sine, remember from SOHCAHTOA. So this is the opposite, and that's the hypotenuse. And it says that this is the angle whose sine is 4 over 5. So if I make this 4, and I make that 5, is the sine of theta 4 over 5? Yes. So now I have an angle, it's positive, 4 over 5. It goes down to be negative. So now I have an angle whose sine is 4 over 5, but I want to find the cosine of this angle. Well, what's the cosine? The cosine of the angle is the adjacent over the hypotenuse. So I need to find what A is. And I can do that using the Pythagorean theorem. All right? We know that A squared plus 4 squared equals 5 squared. So A squared plus 16 equals 25. So A squared equals, if I subtract 16, I get 9. So A equals 3. This is a 3, 4, 5 right triangle, so this is 3. And what's the cosine? The cosine is the adjacent over the hypotenuse. I can use this triangle. I can find all 6 angles now because I've got the 3 sides. Remember, we've done that before. Where using those 3 sides, you can find all the 6 trigonometric functions. So this is going to be 3 over 5. Adjacent over hypotenuse. So that's the technique we'll use on these. Let's take a look at number 49. Now we want the tangent of the angle whose sine is negative 3/5. Now remember, again, the inverse sine, those values are going to range in the first and fourth quadrant. It's positive in the first quadrant, it's negative in the fourth quadrant, so this must be in the fourth quadrant. So I'll just draw my quadrants there. And my triangle will be something like this. So I'll make my right triangle in that fourth quadrant where the inverse sine is negative. Okay, it's the angle whose sine is, or the sine is negative, I should say. Okay, because it's all students take calculus, so it's negative. All right? And again, the notation on this is kind of confusing, so it's best almost maybe even to avoid that. Just kind of draw it out here. And the sine, again, is the opposite over the hypotenuse. So I hope it helps to see these. This is the opposite over the hypotenuse. And if this is my angle theta, this is the opposite. And there's the hypotenuse. Let's try these in a different color. And they tell us that the opposite over the hypotenuse is 3. Now remember, this is going down, so this is where your negative is, negative 3. This hypotenuse is always positive. That's 5. Okay? And again, we've got a 3, 4, 5 right triangle, so we know that this side must be what? 4. Okay? And that's going to be the adjacent. And what is the tangent? The tangent is the opposite over the adjacent. All right? So for theta, the tangent would be this negative 3 over 4. So that would be our answer. Negative 3 over 4, or negative 3/4. I can fill that in right there. I hope you can see that. Kind of got squinched in there. Okay? Hope that makes sense. So again, this is going to give you a way of constructing your triangle. Okay, another nice easy one. Let me draw it over here so we have a little room. And again, this is going to be the angle whose sine is twice. What's 51? Oh, I kind of fouled up. This is what I did. Let me kind of salvage this here. So I'll change these numbers. I copied these down. Okay, this is going to be actually 51 here. 51 is the tangent sine inverse. So this is actually 51. Pardon me. So this is 51. Let's change this to 51. Pardon me. We can do this, all right? And you can do that on your homework if you... So this is 51 here, pardon me, and this would be 49. And I'll just do that on a separate sheet of paper here. I've got some more of these written out anyway somewhere here. Yeah, so I'll do 49 over here. I'm sorry about that. Okay, so give ourselves a little more room. And here's 49. And that's going to be, 49 is the tangent of the inverse cosine of 5 over 13. There we go. Let me double check that, okay? So that's 49. Tangent of inverse cosine. Okay. All right. So I know that this is the angle. Now the cosine is going to be, remember the inverse cosine, the values are going to range, or the angle values are going to be in the first and second quadrant. It's positive, so this will be in the first quadrant, so I think we're okay there. So let me draw a triangle in the first quadrant. And here's my angle theta. And I'm told that the cosine is 5. Now remember, the cosine is the adjacent over the hypotenuse. So this is the adjacent, and this is the hypotenuse. And I'm told that those values are going to be 5 over, so this is 5 over 13. And I want the tangent, and the tangent is going to be the opposite, so I'm going to need the opposite over the adjacent TOA. So I need to find the opposite, so I'll have to use the Pythagorean theorem. And I could say 5 squared plus O squared equals 13 squared. 25 plus O squared, that's not 0, O squared, that's opposite, equals 169. And if I subtract 25, I get O squared equals 144. And the square root of 144, as we all know, opposite equals 12. So this is 12. That's a 5, 12, 13 right triangle, one of our more common right triangles. And what is the tangent? The tangent is the opposite over the adjacent. So that's just going to be opposite 12 over 5. So that's the tangent of this angle. This angle is theta. In other words, we're solving for this. We can call this theta, because theta is an angle. This is the inverse. The arc cosine, or the inverse cosine, is an angle whose cosine is 5 over 13. So this is an angle, so we're going to take the tangent of that angle. The tangent of that angle is 12 over 5. So you just have to think of it like that. Okay? And if you go back and look at, if you look at your notes, this is actually an angle here. I should have marked this. This is actually theta. And this is actually theta all in there. So once we find theta, we can take the tangent of theta. Okay? That's 49. No, I didn't. This is 49 here, pardon me. Let's cross this one out here. And let's try 53 now, because we already did 51. And 53 is the sine of the angle whose cosine is the square root of 2 over 2. Again, it's going to be in the first quadrant because it's positive. All right? It's negative in the second quadrant, so if that was a negative, I'd be drawing my angle over here. Okay, and then I draw a triangle. And here's theta, so this is the theta. We're looking for theta. Well, we won't really find theta, but we'll know what it looks like enough to find the sine. So what's the cosine? The cosine is the adjacent over the hypotenuse. All right? So this is the adjacent, and this is the hypotenuse, and they tell us that that ratio is the square root of 2. over 2. And for the cosine, I need the opposite over the hypotenuse, so I'm looking for the opposite, so that's this over here, the opposite. Okay, so I need the opposite over the hypotenuse. So what I'll do is try to find what the opposite would be. So I know that O squared plus the square root of 2, that's A squared, equals 2 squared. So O squared, and the square root of 2 squared is 2, equals 4. If I subtract 2, I get O squared equals 2. So O equals the square root of 2. Is that all right? Okay. So O equals the square root of 2. Now this is going to be positive, so but it's also in the first quadrant, so the sign will also be positive. So the sign is going to be the opposite over the hypotenuse, so the sign will also be. So this is a nice isosceles right triangle, so that's a 45-degree angle. Okay, or pi over 4. Okay, so I hope that helps. Sorry about the little faux pas there.